Good morning and welcome to the virtual Houston Techfest. Before we start, I want to make you aware about a feature in the presentation that will make the session more interactive. Please make note of the question mark icon at the upper right of the presentation screen. Clicking that icon will open the question and answer feature, which allows you, our audience members, to send the moderator questions to be delivered to our presenter at the appropriate time. We are proud to present William Assif, Principal Consultant at SparkHound, who will be sharing SQL ad best practices with DMVs. The floor is yours, William.
Thanks. So this is an incomplete tour of SQL Server DMVs covering the most important topics and getting you started on getting the most out of these crucial performance indicators. Today's presentation is delivered with a short delay because of the broadcast medium. So if you have any questions, go ahead and submit them at any time. I'm going to pause midway through and then at the very end to answer any collected questions. So let's go ahead and get started. So everyone can benefit from the knowledge of these helpful tools, from developers to report writers to DBAs of all levels of experience. There are far too many DMVs to be covered in the scope of just 1 hour's presentation. So here are the most useful and popular and how to use them and when. Getting anything out of a DMV out of SQL Server will require you to try them yourself. Short, quick-hitting labs will be mentioned throughout, but we won't get to all the labs. In fact, I'm going to skip most of the labs, but you can do the labs and understand what those numbers look like on your SQL Server. I'm going to share practical everyday uses and scripts that I use myself as a DBA. I'll stop for questions in the middle briefly and then same time for questions at the end. Yep, all the slides and code samples will be posted at my blog at sqltech.com, and actually all the code samples are already out there publicly on GitHub, and I'll provide a link to that as well. Some of the slides will use the Microsoft provided Wide World Importers sample database on GitHub. It's pretty easy to find and download and restore to a lab in your own. And when you download the slide deck, there's a link to it right here. And then a lot of the code for this presentation is straight from my team's SQL Toolbox, which is published on GitHub. It's out there for everyone's reference here. Okay, the DMVs we're talking about today are the foundation of countless third-party SQL monitoring applications. But what is a DMV actually? Is it the Department of Motor Vehicles? No. The DMV proxy service? Brilliant idea. No. DMV, the Motor Vehicles mega musical with just one of the Blue Men. No, it's not that. You're on the wrong track. It's not the DMZ. No, it's not Run DMC. It's not the DMV, the DC, Maryland, Virginia rap scene. No, it's not. No, that's Dave Matthews Band, DMB. Dynamic management views are in place to provide system transparency, and most of these go back to SQL 2005. In fact, they're part of a larger category called DMOs, or Dynamic Management Objects. But DMO was actually an acronym already taken by Distributed Management Objects, another thing inside SQL. So DMVs are just a common parlance for it. Some of these are actually DMFs. In fact, they're functions because they take parameters. So some of these DMVs require the database be in the needed compatibility mode as far as the version goes or higher, and some do not. Some toward the end of this presentation have been introduced more recently, including we're going to talk about some DMVs introduced in SQL 2019, which has been out for less than a year. Often then, DMV changes are included for older versions via service packs or cumulative updates. So something may only work in SQL 2012 Service Pack 4, but not in Service Pack 3. So pay attention for that. And then most of this content applies to SQL Server, Azure SQL, SQL on Linux, Azure SQL managed instances, with some exceptions. Most of these DMVs require read-only permissions that may be appropriate for developers, even in production, because they don't grant you access to data just to these DMVs. So most DMVs require only view server state for server level DMVs or view database state for database level DMVs, and you can grant them very easily with commands like this. Ready? Let's get started. This is going to be fast paced. Again, if you have any questions, put them in the Q&A and we'll try to get to them. So, weight stats. Let's talk about weight stats. Many performance suites that you buy do little more than incorporate weight stats data for charts in their dashboards, But all these third-party products are great sponsors of user groups and tech events like this, so they're great. But they are just using the same data that you have access to already inside SQL Server. So there's 3 DMVs we're going to talk about for wait stats. The first is DMOS wait stats. And when you query this in your SQL Server, you'll see records that are aggregating wait times and counts. And these numbers are always going up. So it records the count and times of tasks experiencing that wait type and the max time waiting. There are about 1,100, and they're always adding some more wait types that are some more or less documented in SQL 2019. It is best to exclude some types of waits. For example, there's some types of waits that have the word sleep in them, because those are related to DB system startup or just idling or background tasks, and you shouldn't be concerned if those are a large part of user performance. In fact, there are a bunch of wait types that you actually want to ignore, like on-demand task queue. High wait times here indicate that SQL Server is idle. You're going to see a lot of this on your laptop if you're not doing anything and you're running SQL Server there. These wait times also indicate idling and are not problematic. There's a really good source here of wait types to ignore at the SQL Skills blog by Paul Randall. So let's talk about some of the common waits you do want to care about. So anything that begins with lock M, these are lock waits. This is a sign of transaction contention. I've got this page of data. You want to read it or you want to write to it, but I own it, and then vice versa. This is locking and blocking of queries of each other inside SQL Server. Not a difficult concept to understand, and this measures the amount of aggregate time lost to waiting on those blocks to clear. Observe sysdm tran locks over time to catch those locks in place, and then we'll also talk about the DM exec sessions and DM exec requests where you can observe that blocks happening live. This could be due to poor queries and indexing. In fact, it probably is due to poor queries and indexing, creating too many scans. Scans create more locks, which could create more blocks. So a more efficient query will actually reduce locking and blocking. This really doesn't have much to do with storage, but it could. And then availability groups, and we're going to talk about availability groups. That's kind of the modern SQL Server solution for high availability and disaster recovery. Synchronous availability group replicas could increase this. And then if you have a lot of those lock M waits, consider RCSI. And that's a topic for a whole other presentation, but read committed snapshot isolation is the enterprise way to reduce locking, increase concurrency, and that's much better and much safer than just putting no lock or read uncommitted everywhere. I'm not going to bang too hard on that drum in this presentation, but I'm not a big fan of no lock. It is dangerous to use, even though it seems to make things run faster. RCSI has the same positive effects without the safety problems. CX packet, clear indication of excessive execution plan parallelism, and the CPU is struggling to keep up with all the parallel threads coming through. Look into the max stop settings. I think that's pretty common performance tuning step for a whole server. It may be appropriate to reduce the max stop. That reduces large parallel queries from impacting performance, or the cost threshold for parallelism. Increasing the cost threshold for parallelism will allow only the biggest and baddest queries to go parallel. Maxstop used to be only configured server-wide, but in recent versions of SQL Server, it can actually be set at the query level with an option hint or at the database level. So you can have different databases running at different maxstops. And enforcing maxstop at the query connection level is one of the better implementations of Resource Governor, an enterprise-only feature that identifies queries coming into your SQL Server and then assigns certain caps to them. CX packet in recent years, in recent versions of SQL Server, has actually been split up into two different kind of waits called CX packet and CX consumer. CX packet used to be from threads that both consume and produce data in a query plan. I'm not talking too technical here. Just try to understand fundamentally what I'm saying. Producer threads were actually the most problematic, most impacted by parallelism, and most affected by out-of-date statistics. And so producer threads were something that you actually had control over. You can clear up the fragmentation. You can clear up statistics. So now only producer threads are reported by CX packet waits, and the consumer threads, which you have less control over and are less important, are now reported by a much different wait type. So as a result, since SQL Server 2016 Service Pack 2, 17 CU3, and with all of SQL 2019, CX packet will actually be lower compared to an older result because it's kind of slicing out some of that stuff you had no control over. Now the weights reported by CX packet should vary more as you try to turn the dials for parallelism. OLADB. This describes weights associated with external communication. This is commonly used by SSIS, Microsoft Office applications, including like Excel and Access, linked servers, and other third-party tools that connect to the SQL Server. It could also be generated by internal commands by DBCC CheckDB. If you're aware of all those things, if you're trying to troubleshoot all those things, and certainly if it's being caused by DBCC CheckDB, OLADB is not really a problem. You should just be aware of it. SOS scheduler yield is a clear indication of CPU pressure. Too many runnable tasks for the available CPU threads. Task is stopped, a SQL task is stopped and has yielded to another task. Increasing the number of CPU processors or the speed of the CPUs is simple, but it's crude, it's expensive, it's potentially difficult depending on the platform you're running on. So look for and reduce CPU intense queries. And later, we're going to talk about identifying the worst query plans when it comes to CPU time. That's going to be really helpful for you. Resource semaphores, a request is waiting on memory to be gathered. This is an indication of memory pressure caused by insufficient memory. And of course, the SQL Server can never have enough memory. More likely caused by poor query design. Queries that need more memory than they probably should because of poor indexing or just inefficient query plans. And there's lots of ways that could happen. That's more likely the cause here. Page latch and page IO latch. I know those look very similar, but they're actually completely different. Page latch has nothing to do with physical IO. It has nothing to do with the disks or the SSD or the storage system or the SAN or anything like that. It has everything to do with memory. It could be tempDB temp tables are being overused. It could be an insert statement to a hotspot on a table. We'll talk about that in the next slide. On the other hand, page IO latch. This is physical I/O. This is reading from disk or SSD or flash or whatever it is, but it's the delay involved in reading from that I/O subsystem into memory. And that subsystem, the I/O subsystem, is having trouble keeping up. Often this is because, again, of inefficient code, not disk, not necessarily a problem with storage. Could be that somebody is using Microsoft Access or Excel and pulling down entire tables to their laptop. That could cause a lot of reads suddenly, and it could trickle down into this kind of wait type. It could indicate slowness or a problem in the SAN or storage subsystem, but I would check the queries first. Now let's talk more about page latch, that memory thing. New in SQL 2019, there's an index option for optimized for sequential key, specifically for tables that have an identity or a sequence. So have that system auto sequencing number or auto generating number. And that creates hotspots for sequential inserts. If you observe high amounts of page latch EX on those kind of tables, it could be because of the contention for individual pages in memory due to many concurrent sequential inserts. So you have 10 threads, 10 users that are all trying to write a new record to the same table. Those all happen at that hotspot for the sequence where that sequence is happening. That's okay. Beforehand, it was still better than having like a random key where it's writing all over the table. That was usually a bigger problem due to fragmentation and page splits and things like that. So now, to alleviate this one problem with what is otherwise the recommended solution is this new optimized for sequential key hint for indexes that improves performance up to 30% for concurrent inserts. So those 10 queries all trying to write data to the same table. Add to the definition, add this hint to the definition of any sequential key index. And if you're like me, every table you design in SQL Server starts with an identity column. That's an ID, integer, not null primary key column. Okay, let's keep moving on, more wait types, then we're going to move on to other DMVs. Async IO completion is waiting for disk IO to complete. This is not related to data pages IO though. So this is related to other things besides data pages like log files, backup and restores, or auto growth events trying to grow these files. This is expected during long-running SQL backups, as are backup IO and backup buffer wait types, so that's actually all expected and that's not a problem. Async network IO, a little different here. Async IO completion, async network IO is common, and it's caused by waits involving the reception of data by remote clients. So you have an application that's queried for 10,000 rows. The time spent transmitting those 10,000 rows over to the person's laptop that's running the application is measured here. But it's almost certainly not caused by the network, because the network's like really rarely the problem. Rule number one, it's always DNS, but rule number two, the network speed itself is rarely an issue nowadays. So it's almost certainly caused by poor queries, such as select stars with no where clause, for example. Look for queries with high row counts or select stars where they're bringing back every column in a very wide table. That could be a problem. Again, it could also be caused by Office apps, like somebody pulling down an entire table with Access 97. So when do you want to analyze wait stats? Use this on healthy or troubled systems. Look for trending from a baseline. So try to capture these stats as they happen, as they grow, and then trend them over time. A lot of third-party products do this for you very easily, but you can do it yourself if you don't have budget for that kind of thing. Determine which waits are impacting server performance that are generating the most waits. It's really one of the best DMVs for server-wide performance. Again, the numbers in this DMV are forever growing. So over time, recent changes will not affect the large numbers well enough, and it can make it hard to find. So for your performance sensitive servers, consider a regimen of storing those numbers every week or every day, and then comparing the difference to see how the wait stats are changing, comparing the difference in times, the difference in counts to see how those stats are changing. And I have a lab that helps you do that here. So again, DMOS wait stats is aggregated at the instance level. It doesn't include live data. It doesn't include request or session level data. For that data, you'll need the next DMV, and that, ladies and gentlemen, was a segue. This DMV, DMOS waiting tasks, shows waits for active requests currently happening, and they're not aggregated. So it's not much different from the current information found in DMExec requests. We'll talk about that later. That's a DMV that just shows you what's currently being queried. DMExec session wait stats shows you aggregate wait stats for a current session. And again, a session is a connection. So every tab you have open in Management Studio, the Object Explorer, even in IntelliSense, those are all connections to SQL Server. Those are all sessions, and a session may last for hours or days. A request that we talked about in the last slide, a request is a query that's currently running, and a request ends when the query finishes. So this DMV shows you aggregate for an individual session instead of server-side waits or current waits. And so we could drill into specific waits for a session coming from a specific application. The syntax is actually the same as the aggregate, the OS wait stats, but it includes an extra column for session ID. And there's some labs available here. We're not going to go into them, but they're available at that toolbox and GitHub link that I showed you earlier. Okay, moving on. DMExec query stats. This stores performance information about cached query plans in memory. But the rows do not persist after a plan is removed from cache or if you reboot the SQL Server. This is going to be the first time of many times that I'm going to tell you that rebooting a SQL Server is not a performance tuning step. One of the problems with rebooting a SQL Server, aside from flushing everything out of memory and having a whole bunch of disk I/O to bring it all back into memory, is that you lose a lot of really valuable performance data like this in DMVs like this and in some of the indexing things we're going to talk about later. You basically query the DMVs and no rows come back because those are all passively collected, and you lose that data whenever you restart the service, the SQL service, not just the SQL Server. So be careful about that. Don't just reboot a SQL Server; it's performing badly. DMExec query stats provides a SQL handle and offsets. We're going to talk about this, a very common thing. You'll see this in the labs that help you identify the statement within a batch or a stored procedure. So if you have a very long 3,000 line stored procedure or trigger or something like that, you can identify which individual statement in that batch that's actually running right now or causing the problem or occurring these stats. Find the worst query plans in terms of total worker time, which is CPU, in terms of rows affected, or in terms of total duration. So this DMV records total writes, total reads, and can be used as a summary to measure activity. And then you can rank all the plans that are currently in cache in like a worst query plan. So that lab, worst query plans, is a great place to start if you're running SQL servers older than 2016, because with SQL Server 2016, we got this new feature called the query store, and it actually contains more and better data and functionality than just the DMV itself, including a whole graphical interface built into Management Studio. Query store is so good, I actually no longer use my own worst query plans scripts in my own toolbox anymore. SQL Server 2016 and above, you need to enable query store if you have something running like that right now. It is not enabled by default, and there's very little overhead. Let's talk a little bit about query store, then we'll get back on topic. So this was new in 2016, and then starting with 2017, the query store tracks wait stats too. So that first thing we talked about with wait stats, and now this second set of DMVs, all that is all together with you in a graphical interface called the query store in SQL 2017. The query store tracks performance of queries, not of execution plans, and this is a distinct difference. The query store can detect when a query has suffered degradation because it changed plans, and it can actually identify the plans that you're running and help you go back to a better plan. So while the worst plans in cache had been a strategy to identify the most expensive plans, the query store is one step better, finding the worst queries, regardless of plan. So what's the next step? If SQL Server can use information about regressed queries and a history of execution plans for every query, couldn't it automatically choose a better plan? Yes, now it can. Automatic plan correction is available in 2017, and an Azure SQL database, the PAS offering in Azure, it actually already does this for you automatically. So automatic plan correction is based on the query store. It's available in Azure SQL 2017. It can force a query from a newer, slower plan back to an older, faster plan automatically. There's lots of reasons new plans can be created, and this is one that really helps overcome that classical problem. Again, this is not on by default, though. You have to enable it. And you can accomplish the manual plan correction yourself by querying the underlying DMV for that feature, DMDB tuning recommendations. And there's a sample right here. So I'll pause right here. At this point, any questions that have come in, Sherwin?
None so far.
Great.
I think there'll be some in a second.
Yeah, well, I know I'm also hitting you with a lot of information right here. So if you have any questions at this point, or in the future, just drop them in the QA. We'll get to them at the end now. All this will be available, and I highly recommend going all over all this stuff on your own SQL Server. So the next query DMV we're talking about is DMExec sessions. So this is queryable session info. It includes connection identification. So again, a session is a connection to SQL Server, even if it's not doing anything. A connection may be open for days or weeks, right? Management Studio, every tab is a connection, every tab is a session. So you can identify where all those sessions are coming from with this DMV, and so it replaces an older system view. If you're an old DBA like me, sys.sys processes, and this is often joined to sys.dmexec requests. A request is an actively executing query. So this shows current activity, kind of like SP-who or SP-who2, which are these old built-in system procedures that return information about what's currently happening. You can get way better and way more information out of DMExec sessions and DMExec requests. DMExec requests is actually the main hub for other dynamic management objects providing request info, and it's often joined to many other DMVs to find out what's going on right now. It also provides you that SQL handle and offsets to identify a statement within a batch or stored procedure using that DMV we already talked about, DMExec SQL text. You can find out exactly the SQL text of what's executing right now. We talked about that DMV earlier. So with both sessions and requests pulled together, you can find out way more detailed information than SP-who2. And in fact, this is a really good example of why I wrote a query just like this for my own toolbox called sessions and requests, which you can pull down from the GitHub lab and execute on your own server. What we had here was, imagine you only had the rightmost column blocked by. That's all you get with SP-who or SP-who2. And looking at just those numbers, you see that there's a lot of blocking happening, but you have no idea what's at the root of all that blocking. It's hard to kind of figure out just by eyeballing it, what's going on here. So sessions and requests, the way I wrote it, it pivots that data and then it introduces the blocking these category to show all the requests that a single request is blocking. And you can see here then that I have ordered the length of the blocking these chain descending as my order by. So the longest blocking chain appears first in my query. And sure enough, that brought to the top of my result set that session 623 was blocking all those other queries. And it was not blocked by anything. And turns out that was just a hung SSRS report that had millions of rows locked up in a big long running report, killed 623, all the blocking cleared out. And that's why I wrote this back in 2011. So this also includes a very useful % complete column in sysdm exec requests to check the progress of backup or restores. So knowing when the backup or restore began and its % complete, you can then provide yourself an estimate of when it's going to be done. And the same thing for DBCC check DB operations. That % complete thing is there, and it's actually pretty accurate. Combined with that start time value, you can then estimate the completion, and there's a lab for that. So DBCC input buffer, if you're familiar with that, it's used to figure out what the last command was passed into SQL Server from a given session. It's actually still not deprecated for various very detailed reasons or minor reasons, but it's been effectively replaced by a DMF, so a dynamic management function called DMExec input buffer. And that's what you can use to find out what the last query that was run by a given request, even if that query has already finished. So let's talk about indexing DMVs now. There's 3 different categories of indexing dynamic management views I want to talk about. The first, physical stats DMVs. This helps you evaluate the need for index maintenance. The second is to help you design new indexes, and that's the missing index DMVs. And the third is the usage stats DMV, which helps evaluate existing usage index. So the first tells you what indexes you need to maintain. The second gives you some clues as to what indexes might need to be created, but we'll talk about that. And then the third tells you if indexes you've created are actually helping you. You need to be evaluating this stuff regularly inside your SQL Server, so let's dive in. So the first, DMDB index physical stats determines the index fragmentation so that you can drive your maintenance from that. So all index fragmentation monitoring queries that you might find out there, including what's built into SQL Server's maintenance plans or the Ola Hallengren scripts or anything that you write yourself, is going to be based on this DMV. It shows you that average fragmentation in %, which is logical fragmentation for indexes for extent fragmentation for heaps. And it replaces the functionality of the old DBCC show config to an extent. That's a pun because 8 pages is an extent. Anyway. SQL jokes. So DBCC show config used to be what you had to use to find fragmentation. Now we have these queryable DMVs. This will still show tables without clustered indexes. And that's an index ID equals 0, and that's a heap. And as we all should know, a table without a clustered index is a heap, and that's a derogatory term because a heap has no order. And so it can't really have a lot of fragmentation because we have no idea if the page is really next to each other, if they're supposed to be next to each other, because there's no order to the table. So almost always a heap is a poor design. And I would argue an oversight in a queries. There's a query in our toolbox called tables without clustered indexes. You should go fix all of those. However, a heap fragmentation isn't really meaningful. So when you're querying this DMV, I just ignore anything that is index ID equals 0. Index ID equals 1 will be the clustered index, and in SQL Server, every table should have a clustered index. A lot of folks who come from other database platforms don't understand how important the clustered index is to tables in SQL Server. Every table should have a clustered index with very few exceptions. Index ID equals 1 is the clustered index. Every value above 1 is a non-clustered index, including a column store non-clustered index. So the average fragmentation is a scale of 0 to 100, where 0 is good, not fragmented, and 100 is perfectly fragmented. Everything is perfectly out of order. It's not a good state to be in. So you may find it beneficial to perform some sort of index maintenance when average fragmentation is above 10%. This may vary. You may find a better balance of meaningful performance protection and then log maintenance activity with a less aggressive maintenance, like maybe only defragmenting things above 50%, especially if you have a very tight window that you operate in, like if you're a 24/7 shop and you have very few opportunities to do meaningful index maintenance. And just an update for all the old DBAs out there, all these DBCC commands have been replaced. We use alter commands now for index maintenance. So when do you do index fragmentation? When do you observe this? So use this while your application is in production, sure, to identify tables that are generating fragmentation over time. And then only perform index maintenance on the individual indexes as needed. And then potentially, if your table's partitioned, only perform index maintenance on the partitions of indexes that are needed. But be aware that when you run this DMV, it has an impact on performance because it hits IO pretty hard. We'll talk about that in a sec. So ideally, you rebuild or reorganize, and those are the technical commands, the most fragmented tables in every maintenance window. You kind of take it off the top. So run your index maintenance for an hour or two every night if you can, if you have that kind of maintenance window in the middle of nightly operations. Your custom scripts could choose this to be selective, right? You could pause your index maintenance, have it not start anything new after a certain amount of time, or you can use the new resumable index maintenance features that are available in newer versions of SQL Server, I believe in SQL 2017. If you're 2017 or above, and you're writing your own index maintenance, definitely look into the resumable index maintenance feature. Even if you're not writing your own index maintenance feature, though, you have a small or a relatively simple SQL Server and you're using maintenance plans. Maintenance plans have actually dramatically increased in capability and quality to perform complex conditional index maintenance operations. So on the left here, you see the index, the rebuild index task that was available in maintenance plans in SQL 2014. And notice it's really just going to do everything in the database. There's no filters. It's going to hit the entire database, and this is definitely not recommended because it's very doubtful that all the tables in your database are fragmenting at the same time and need maintenance. On the right here, we see what this index rebuild task looks like in SQL 2017, and you can see all these filters at the bottom that allow you to say optimize index only if the fragmentation is above a certain percent, or even if it's of a certain page count. You just want to skip the smaller tables, only focus on the big ones. That's pretty useful. That's the kind of thing I'm talking about when it comes to index maintenance. You don't want to do a whole database index maintenance. It's just going to take a long time, waste a bunch of log. Okay, so let's talk about the parameters for this DMF technically. So by default, it does this limited scan. And at the very end of it, you'll see that command, that parameter for limited. You could also do sampled. It's not as fast. It does sample. It's going to be a little bit more accurate. And then detailed's much more involved. It scans all the data pages in a table. It will hammer your IO subsystem. So do not run this DMV during production hours. This should be only run right before you do your index maintenance, also a very intense operation, during index windows. So this is at night and weekends and things like that. Detailed is the only way to get some of the columns populated, but you rarely need those columns. Just to get the fragmentation percent column, which you really are driving your index maintenance off of, you just need to do limited. Even limited, though, can impact performance by tying up a whole bunch of IO resources, by making your SAN real busy. So just don't run this during the day just for curiosity's sake, okay? Here's the lab. We're actually going to do this lab to talk about fragmentation and to talk about those clustered indexes a little bit here. So I'm going to switch over. And so what I'm going to talk about here is a query. And I think everybody can see this query. A query that is going to show, I'm just going to create a real simple table here. And I'm going to put a primary key clustered index on it. Very good idea. I'm going to add another non-clustered index to it just to show some results later. And then I'm going to insert a whole bunch of data into it. I'm running all this on SQL 2019, running in an Azure VM, but this is going to behave exactly the same way all the way down to SQL 2005. This behavior is unchanged. So I'm just going to insert a whole bunch of data into the table, and I get back my query, 131,000 records in it. And I'm going to go over here to a defrag.sql, and this is all in that same GitHub laboratory. And you'll notice at the core of my query here is the DMV that we're talking about, DMDB index physical stats. And I've passed a bunch of parameters, including even that limited thing. So now I'm going to go see what the fragmentation level is for my table. And so you can see also that I've joined this query to some of the other system tables like sys indexes, sys partitions, sys objects, sys schemas. And what I've built myself are alter index all reorganize and alter index all rebuild commands. I've built these things out for me. So if I want to do index maintenance now, I can. So this is a pretty handy query. And this query itself is at the root of another query called automated index maintenance that we use to schedule to do our index maintenance plans. But you'll notice right here that, I just inserted 131,000 records into my table. And the hair on the back of your neck is standing up. And you're like, wait a second, if you just did inserts, how is this table almost perfectly fragmented already? Look, 99% fragmentation. But all you did was inserts. They should have gone in order, right? At this point, if we were all standing next to each other, I'd ask somebody in the audience to pick it out. The problem with this table that I created is that I used the unique identifier data type, and that became the primary key clustered constraint. And a unique identifier is a random 16-byte string, alphanumeric, random. So every row went in a random order, not sequentially. So the first row went in, the second row went in, the third row went in the middle, probably, and split the rows up, requiring a whole bunch of I/O to create two new tables. Page splits happened basically by default, and so we perfectly sorted out our page data for this table, 131,000 records, in a fragmented way, in a random way. Well, that's bad. We don't want that. That's really bad for performance. So the better way to do this, and like I mentioned earlier, every table that I design is an integer, not null, identity column that is the primary key clustered index. And you'll notice I'm also going to be using this optimized for sequential key thing I'm going to talk about a little bit later. Or that I already did talk about. That's right. I talked about this in that presentation already. So let me do this with a proper design table by grown-ups with a real data type, integer, same number of records, same exact data. I just put in a bunch of gobbledygook data in there, right? So just if you want to see the data in there, it's just a bunch of alphanumeric stuff. Same data, right? Just with a bunch of random characters being assigned random lengths and intervals. And let's go look at the fragmentation of that table. That's the row that came in, and just inserting 131,000 rows, we have almost no fragmentation. A marginal amount of fragmentation, nothing. And you'll notice the impact of that fragmentation too. It's 50% smaller just to store the same data because I made a better data type choice. Not fragmented, and an integer is only 4 bytes. Even a big int is 8 bytes, whereas a unique identifier is 16 bytes. So just to store the key of the table is 4 times larger than you need it to be just to store an integer, right? We're talking about table design here, and this is a really important topic. So then you say, well, William, unique identifier has this new sequential ID thing that's really cool. It creates sequential unique identifiers, and that is a superior option. Well, okay, fine. Let's do that thing. We'll do the same amount of data, 131,000 rows. And let's look at the fragmentation there. And you see that this is the new sequential ID row that just came in, and the integer one's at the bottom. And so indeed, it has solved the fragmentation problem for now, even though it is still more than 50% larger as a table. And that storage echoes into memory, it echoes into backups. Bigger problems you've created just by using a unique identifier, even if it's sequential. But there's a catch to that new sequential ID function. Resets the seed anytime you restart the SQL Server. So you start writing a new range anytime that changes, anytime the NIC changes. In an Azure SQL database, anytime it gets reallocated. In an Azure VM, anytime the gets deallocated and reallocated with a different network card, because that's the key for the new sequential ID. It is not the solution. Don't use unique identifiers as the clustered index. If you use unique identifiers, and I understand there are some arguments for that, just don't use them as the clustered key of your table. All right. back to our lab here. Anyone know why the Microsoft Windows 7 release candidate download page broke? It started timing out. It was because of exactly the same reason. Somebody inside Microsoft had used a unique clustered index on a unique identifier that was just generating random keys, and it became so fragmented that queries on that table started timing out. And it's all detailed in one of Paul Randall's blogs right there. On his blog, Paul Randall, the guy who wrote DBCC CheckDB and a lot of other stuff for Microsoft. You still see this anti-pattern happening in some Microsoft products because developers aren't getting this message, including in CRM. You see clustered index keys on unique identifiers, random unique identifiers. Still a problem. Now you know better. Take that power and go with it. All right, moving on. Let's talk about column store indexes, brand new type of index that was created in 2012, but it's really become a lot more popular in 2016. It has its own way of doing index maintenance. So column store indexes have their own DMV. It's this really long DMV right here, column store, row group, physical stats. You need to include this index, this DMV rather, in your index maintenance plan if you have column store indexes. And if you have a table with more than 10 million records in it, consider having a column store index on it, especially SQL 2016 and above. Much useful. Column store indexes were read-only in SQL 2012 and 2014, so they had really limited uses. You basically had to drop them and create them every night, and it was only appropriate for a nightly refreshed workload like a data warehouse. But in 2016, they're writable, so you can put them on a transactional table in an OLTP design. For the column store index maintenance, you only do reorganize, by the way. You don't do rebuilds. You can, but you only need to do reorganize. But you may find it necessary to do multiple reorganize to get it all cleaned up. And there's a lab to demonstrate that kind of thing. So when I do index maintenance on column stores, I actually issue 3 consecutive reorganize steps, and that gets it all perfectly cleaned up. Okay, missing indexes. Let's talk about one of my favorite features that was introduced in SQL 2005. Yeah, so it's kind of old, but I was around then. I was like, wow, this is great. This is a set of DMVs that record whenever a query plan is recognized that the need for an index that could have improved performance. So this is a categorization of indexes that don't exist, but SQL wishes they existed. This is really valuable for developers, for BI people, for reporting writers. Let's dive into this. This is really cool. It's passive. It's already running. It doesn't need to be enabled. It's already been collecting data for you, but you do lose it whenever you reboot the server. So again, rebooting the SQL Server, not a good performance step. So it only recommends non-clustered indexes. We've talked about some other types of indexes already. The clustered index, which is key to the table's order. There's only one clustered index on a table. And then the column store indexes. It doesn't recommend anything like that. Column store didn't even exist in 2005 in SQL. So this only recommends regular, non-unique, row store, non-clustered indexes. It also doesn't recommend XML or spatial type indexes or any other kind of special indexes like that. So it must be used with sobriety, though. Don't create every suggested missing index or your rights will suffer. This is a problem because the missing index feature generates a lot of overlapping indexes and duplicate indexes or nearly duplicate index recommendations, not duplicate. Non-clustered indexes physically exist as copies of your table, and they must be kept up to date too. Thus, they have overhead whenever you create them. So you want to have a good small set of indexes that help many different queries. You don't want a lot of indexes in a table. Writes, though, can actually benefit from non-clustered indexes by making the source of the write more efficient. So an insert statement may actually run faster with a better index, not because of the insert, though, it's because of the select that's in the insert statement. Indexes should be created rather to help many queries. Many index suggestions. Suggestions may only differ by a couple columns in the include or by a small number of columns in the key. And while the column order of the key does matter, the column order of the include list of an index does not matter. So feel free to combine all those together to create one index to rule them all. Combine existing indexes on the table as well. So you may find that you have a new suggested index that overlaps an existing index. We'll drop that index, create the new index, right? And that way you have one index serving up all those queries that have been generated over time. Be careful, though, not to change the uniqueness of a table, right? A unique non-clustered index, the same thing as a unique constraint, shouldn't be changed to be added on to a missing index suggestion. So when do you want to use this? Use this in actual usage in production. Don't do this during development. It's too misleading, the activity that developers will do. You can do this during user testing if it's actual usage that's being simulated. Do this on your production environment after a stable period of active and typical activity, but then try to capture an entire business cycle. So, for example, weekly payroll or month-end reporting or quarterly or annual reporting. Try to understand the business cycle and generate suggestions based on that business cycle. This is even more important in the next DMV to understand. Now, since 2008, we've actually seen this green text show up on the screen whenever we're running a query and looking at its execution plan. This is a missing index suggestion. However, this is just one missing index suggestion. Remember, we've already talked about needing to combine many index suggestions together to create one good super index. So whatever you do, don't create this index. Take this as an alert to go look at all the missing index recommendations for the entire database. Combine those together with the existing indexes in the table, and then start creating indexes to serve it up. There's a lab here. You can walk through generating a recommendation and generating a new index yourself. Let's talk about index usage stats. This is going to help you determine how indexes you currently have are being used and whether or not they're providing value. So it tracks access operations on all indexes cumulatively. So again, you lose all this whenever you reboot the server. And then you can join it to sys.indexes, and you can get information about how indexes are being used. So you track the activity in this query by user lookups, user seeks, and user scans. This indicates that the query, that the index is benefiting you. The index is being read from. So if you have 0 values in lookup, seeks, and scans, it means that this index hasn't benefited you at all since the server's been recording. The user updates column then records the sum of the times where this index caused you overhead, because when you had to update the index, it did cause that overhead for you. So the criteria could be different based on the intended table usage. For example, a reporting table will probably have a lot of lookup, seeks, and scans, but very few updates. And an OLTP table, like a transactional table, might have a lot more updates. That's okay. So you want to use this to identify indexes that can be dropped, because indexes that have 0 values in lookup, seeks, and scans over a period of time that you understand the business cycle should be dropped. So only observe this and really only take action on this after a stable period of actual production usage. Try to, again, understand the business cycle, weekly, monthly, quarterly, annual. And you can look at this index usage stats query in your database, and that's really important. So again, just to recap, the index DMVs that we've talked about. We talked about the physical stats, which helps with your index maintenance, determining what's been fragmented. Missing index DMVs to figure out what indexes need to be created, and then index usage DMVs to figure out what indexes need to be dropped. All right, now the remaining time that I have left, I'm going to go rapid fire through a bunch more index DMVs, and then I'll get to some questions. DMOS performance counters gives you perfmon stats from within SQL Server. You can query with T-SQL instead of WSQL, or using perfmon in Windows, or whatever it is that you want to use in Linux to get those same informations out. It replaces the old deprecated sys.sysperfinfo. In fact, most things that have sys in the name of it are deprecated now. It includes hundreds of the metrics that perfmon has that begin with SQL Server colon. In some cases, it may actually be a little more involved to get the number out. So for example, to get the buffer cache hit ratio at a useful memory usage counter, you actually have to do division between 2 numbers, whereas perfmon just gives you the product, gives you the result of that division. There's a lab here you can look at. Page life expectancy, which is another really important memory counter, is another number you can pull out of this DMV. So really good stuff for measuring whether or not you have memory pressure out of this DMV. SysDMOS memory also has memory information. This includes the total and available physical memory and the cache levels and that page life expectancy and more memory related data. It also has some low-high memory flags, and these signals come from Windows and are part of the virtualization feature. If you see a low memory flag pop up, your application could actually query this DMV, recognize that the SQL Server is running low on memory, and scale itself down. Or if you see the high memory flag, you know that you have room to grow. The application could scale itself up as far as parallel threads go, for example. That's really useful for dynamically scaling applications. DMOS host info includes host information and version info for both Windows and Linux. And so you can get information about it regardless of what platform you're running on, because yes, since SQL Server 2017, Microsoft SQL Server runs on Linux. Multiple distributions too, Red Hat is preferred. So in your inventory or your diagnostic queries, this replaces another DMV, obviously, DMOS Windows info. Well, now it's DMOS host info, returns the same data, but across all platforms. DM Server Services returns information on the SQL Server services that are running, including the last time they started up. So you want to see how long the server's been online, you can do that. Information on whether or not the agent is running, that's pretty important. And a much easier way to find out if instant file initialization is enabled. More on that in other presentations, and it's well documented online, but instant file initialization is almost always a big performance benefit across the board in SQL Server. You can make sure it's online via this DMV right here. DMOS volume stats, you bypass WMI calls, bypass your monitoring app, find out exactly how much space is available on your SQL Server volumes. Unfortunately, it only returns information about volumes on the server where there are SQL files. To get all disk info, you can actually still use the old XP_fixed drives to get information about available space on those. And there's some labs here you can use that. DMDB log stats, this is for a one-stop shop for all transaction log metrics. It's actually a newer DMV introduced in 2016 and 2017. It's actually introduced in 2017, but then made available in 2016 in Service Pack 2. It includes a lot of info that you used to have to get out of DBCC log info. And the DBCC commands were great, but you couldn't exactly query them and join them together. The DMVs provide that same information, but you can query them, you can insert them much easier than the DBCC stuff. DMIO virtual file stats includes an ascending counter that can be used to measure data volume over intervals. So you can see what are the busiest files. Is this file getting read from or written to in what ratios? That's useful information for storage, perhaps. And then you can get stall information for IO performance and latency as well. So really good, useful information right here on file stats for both IO and usage across your database. And then there's some DMVs for running your availability groups, right? And again, it's not a DAG. A DAG is a database availability group, which is actually a Microsoft Exchange term, and that's been around a lot longer, and that claimed the concept of DAG. In SQL Server, we do not use the acronym or the initialism DAG or DAG. We just use availability groups. And always on is just a marketing name. Again, it's just availability groups. DMHADR cluster gives you some information about the availability group that you have, so you can set up your own monitoring. That's probably better than what Management Studio gives you in the availability groups dashboard. And so you can combine this with some other DMVs in the HADR category, and this lab for AG Monitor, fantastic script just to measure what's going on in your availability group. You should always run it on the primary replica though. All right, I'm going to leave a few minutes for questions. Here's a whole bunch of links that have been useful to me in creating this presentation, so I share them for you just in case they're helpful to you. There's lots of links throughout the slide deck as well. Here's some books I wrote for Microsoft, the latest of which came out in March before all this happened. On SQL Server Administration by Microsoft Press. It's not a lot of fun writing a book, but it is kind of cool to have it out there. Please support your local STEM initiatives. Here's a STEM education nonprofit that I volunteer a lot for and that is special to me. Please reach out and share your knowledge with the next generation, and especially with folks in your community that are needing to find new careers during this pandemic. Please try to find a way to volunteer in STEM education. And finally, here's some information about me. You'll find the video on HoustonTechFest.com, and you'll find this PowerPoint presentation on my blog at SQLTact.com. I'll now go ahead. Shervin, do you have any questions?
We have about 5 minutes. We had a couple questions for you. The first one I'm going to ask you is, I'm a warehouse ETL developer prepping data for now analysts using Power BI. Are unique IDs and clustered indexes still appropriate for flat and wide fact tables in a star schema? Yeah,
so no. Unique identifiers, so the 16-byte random string and clustered indexes are not a good mix. I would much rather you put an identity column at the front of a table, even if it's a data warehousing table or a large denormalized table, dimensional design, star schema, Kimball method, all that kind of stuff. Even if it's a factor dimension table, I would much rather it have an integer identity column than a unique identifier as the clustered key. You can still put a unique identifier in there later on in the table. Understand that if you put a non-clustered index on that unique identifier, you have the same problem. That non-clustered index is going to fragment itself upon insertion. And you have all those problems about wasting your index maintenance, defragmenting an index that is just going to fragment itself up again. The other thing about the unique identifier is that it has no business value. Right? It's randomly inserted. Even if you use the new sequential ID, it's eventually going to be randomly inserted and cause fragmentation. Whereas an ID column has business value. It ascends as the business uses it. And so that has value to you. You can use that for tie breaking when you have duplicate records or you're trying to figure out slow change dimension type 2 stuff. So it has business value. Strongly recommend even in OLTP or OLAP designs to use ascending keys. Identity is a way to do this, very common way to get that auto sequencing number. The sequence feature in SQL Server is another way to do that. That's a way where you can reserve a number for yourself out of a sequence and insert that into the table later on. And that's a way to prevent yourself from inserting a row into the table and then querying that row to get the ID back out, or using add identity or something like that, and then having to insert another row for a foreign key table. You can prevent that round trip by just using a sequence number. You can reserve the sequences for both tables and insert them right then and there at that same time in the right order for the foreign key. So either identity or sequence, strongly recommend using integers as your clustered key for any table indexes, especially the clustered index. Good question.
Well, maybe a couple minutes ago, well, this will be our last question for the session. Can you tell us a real-time application or scenario of using query store in SQL Server 2016 and beyond?
Real-time application scenario, sure. So query store is like a black box for the database. Let's say that you get an email and you don't see it until lunchtime that the server was slow this morning. Query store allows you to go back in time. Obviously, you've turned it on. Go back in time, look at 9 a.m. and you can see the most expensive queries that were running at that time. And sure enough, Karen down in reporting or accounting was running a huge report and slowing up the whole thing. And we told her not to run that report with those parameters, right? And sure enough, that query was running for a very long time there. We can go see what weights it was incurring. We can go see its execution plan. We can go see, its duration, the CPU, the memory that it used, and all that kind of stuff. And that's your perfectly good explanation for helping that out. Oh, then you say, I really want to do performance tuning on this thing, but I don't know where to start. You can use Query Store to look at a whole week's worth of activity and find the most expensive queries that are running over the week. Start performance tuning at the top, right? What we used to do with the worst query plans is just say, okay, here's the worst plans in cache. Let's find the biggest, heaviest one and start tuning that query. Well, now we can do Query Store and we get much better results as far as the time frame that it was executing in. And again, the query, not just the query plan, but the query. And the other thing Queries Store is really good for is finding out if the query has regressed because it got a different plan. Drifting statistics, drifting parameters due to parameter sniffing could all cause a query to be regenerated with a different plan. And maybe that plan is better or worse. If it's worse, Query Store can help you identify that and even force it back to an older plan. Query Store is not on by default. You got to turn it on. By default, in before SQL 2019, it only allocated itself 100 megabytes inside the user database. It stores all this data in the user database. So you got to be aware of that. But initially, that footprint of 100 megabytes was woefully too small for most large databases. So for a lot of the largest databases that I manage, I've gone and added on 2 zeros to the end of that. So allow the Query Store to take up to 10 gig of data, which, for a 1 terabyte database is nothing, 10 gig. And that's what allows it to keep enough data to be useful to it. If the Query Store runs out of space, it'll actually put itself into a read-only mode, or it could potentially fail. The reason that the Query Store has no overhead is because it is constantly collecting things in memory, and then every 15 minutes or so, and that's configurable, flushing it to disk. So it's not constantly writing data to the disk. It's all in memory, and it uses a very small sliver of memory considering everything else that's going on in SQL Server. So that's how you can get this really, really valuable performance information with low overhead, and it's all a built-in feature. And there's really no third-party products that compete with it either. Query Store is such a new product built into SQL Server that it really is valuable like that. I think I'm just about out of time. But anything else, Shervin?
That was the last one.
All right, well, great. Thank you, everybody. Enjoy the rest of your day for Houston Tech Fest. I think I'm up next in about 8 minutes with another presentation with my wife, Christine. We're going to be talking about ethics in data analysis, ethics in modern data. It's a really important presentation. Regardless, I hope you have a great rest of your Houston Tech Fest and a great weekend. Thanks.
Thank you all for attending today's session, and William, thank you for sharing SQL admin best practices with DMVs. The recording of this session will be available at HoustonTechFest.com shortly. We hope you enjoy the rest of virtual Houston Tech Fest and have a great day.